Our second query then is those profile cards on the A to Z page. I want to show you how we build those. Each profile card, there's two main elements. There's the player's name, and there's also a profile picture of them in the colours of that club. And I've picked Nicholas Anelka deliberately because he's played for quite a few Premier League teams. And the last thing you'd want on the Chelsea site would be to see him in, say, his Arsenal colours, for example. You've got to get these things right. I know it's a simple thing, but it allows me to show you a neat feature in Neo4j that we're going to use. So here's our entities. Now we already know how to find players, first of all. We've just covered that already. And what we're going to do is we're going to feed that into an aggregate query using the with keyword. And so we're filtering out any duplicates that may be there. So we're passing in P, which is the list of matched players of our person record. And we're passing in T, which is the team Chelsea. We're passing in that record so that we can use it later on in the query. So that's what the with keyword does. It allows us to do these aggregate queries. Now, when people write aggregate queries for the first time, they're normally thinking of a reduction set. Write a query to create a large set and then feed it into a second query where you can reduce it even further, and it's just an easier way to express that as a two-way filter. That's what people normally start with. But the nice thing about aggregate queries, you can actually add records in. You can find new records and put them into your final result set, which is really neat. And that's what we're going to do. We're going to find their profile pictures and add them in. And that's the query that does that. So to break that down, first of all, we're not using match, we're using optional match. You see, not every player has a profile pic. I mentioned this history goes back to 1905. And some clubs, of course, were playing in the 1800s. Photography wasn't around in general use back then. It may not even been around at all when some of these football clubs started. My history is not good enough to say. But the likenesses of some of these players has been lost forever. We don't know what they look like. There's no image our historians been able to find for that. So there may not be a profile pic. So that's why we're using optional match, because we want, if there's no profile pic, we still want the player to come through, and we'll just put a default picture in. But we don't want to put default pictures in the database. We'll deal with that in the logic as a client code. And that's just for the slides to say why we're doing that. I mentioned we want to find players in their team colours, and the right team, not the wrong team. So that's why we've passed T down, so that we can hunt for pictures associated with the team. And that's how we find the profile pics. Notice the profile pic is a relationship. It's not a type of record. All the images in this data set that are on file, whether they're profile pictures, people holding cups aloft, whatever, historical moments, they all go in the same record type of media, because at the end of the day, an image is an image is an image. It's the relationship that tells us what that image's use is. It's providing the identity of that image so that we can use it in the right context. And we love that because that's how real life works. That is how things work in real life. When you get away from the bubble of the virtual stuff and you start playing with real things, especially stuff that predates digitization, that's just how most things work. And a great example of this is UK addresses. As you probably all know, you can actually buy a list of all the addresses in the UK. It used to be called the postal address file, if memory serves, the PAF. I don't know if it's called what it's called these days since privatisation. Maybe it's still got the same name. So you get a list of addresses. But the type of address, an address can be different things. It can be a delivery address, it can be a billing address, it can be a home address, it can be a registered office address, and it can be those things simultaneously. And that's, in a graph terms, that's where relationships come in. We'd use the relationship to help us understand what context we're using that address in. And we'll come back to that in a moment. We've got some more slides on that further on. But graphs are a natural way to do this kind of modeling. Now, I keep mentioning about CYPHER returns rows and not object graphs. So we're using a new keyword here called collect, because there may be more than one thumbnail. In fact, I know for a fact there's nearly always more than one thumbnail per player, because different resolutions for iPhones and iPhone X's and Android phones and desktops. So with collect, you can actually create an array of profile pics and return them on the same line, which is really neat. It's not very well described in documentation. It takes a while to get your head around it. But once you start doing it, it's a nice way to solve problems when you've got a semi-open-ended data set like that. So we're going to get one record per player, but that record may include a list of how many pictures there are of them. It's really neat. Yes, please.
Why is the M in collect in square?
To tell Neo4j to return it as an array.
Right. So it's nothing to do with being a relationship or an object.
No. So we know we're looking for one or more media. So M's the media picture. The media. Let me just scroll back to where that's highlighted. So M here is any pictures we find. And we're hoping there's going to be more than one. So the syntax to tell Neo4j to put there's going to be an array of them, collect them together, is to put them in a square bracket. Yes, please.
If it doesn't find a picture because you've used optional map, you said it's incomplete, will it return an empty array with that player, or
Yes.
does it not include the
It will return an empty array. So it will still return an array called profile pics, but the profile pics array will be empty. It'll have no members. Yes, please.
So following on from that syntax, is the syntax for a relationship actually also a list of relationships? Or is it only a single relationship in that match?
That's a good question. It's always described just as a relationship without any singularity or plurality in the documentation that I can recall. But in reality, you can have two relationships between the same records with the same name. You can have two instances of played for example, which is why we're using distinct. So it must be returning, but the thing is they're returned as separate rows. They're not actually returned as an array. Let me just highlight the text. Let me highlight that top bit for a moment. One moment. There we go. So we can have multiple, if there's more than one relationship between the same team and the same player, but the relationship's called played for, what you'd get two rows back, and that row would contain T. It wouldn't contain the relationship because I've not named it, but it would contain P as well. So you would get two rows back.
Yes.
So you could say it's sort of giving you an array.
Because in theory, you could have two named relationships and return data back with the relationship.
Yes, you can, in theory. But it's a very good way of looking at it. Neo4j doesn't describe it like that. It's a very good way of looking at it. I like that. But they use square brackets just for the match line to differentiate from records, is how they describe it in their docs.
But they could have used any. They could use braces or something.
Yeah, they use braces for something else. They use it for parameter expansion in queries, which we'll get onto in the PHP section.
So it's not deliberately extending over the
No, they haven't deliberately overloaded it.
Just on that as an example, so like a person's played for a team, would you be able to store data against the relationship as well? So would the played for include like when they started playing for them and when they finished playing for them, that sort of information?
Yeah. The historian has modelled that separately in a record he calls the spell. The spell's got other metadata about that, but we could have put that as a relationship rather than an entity. Also, I've just noticed that query is the wrong way around. It should be person played for team. I've stared at these slides for 20 odd hours and I have not spotted that until you guys have started asking questions. It's the wrong way round. Oh dear. But no, we could have done those as relationships instead because we can put data inside them. I don't know why we didn't.
So what's the relationship with data in it and a table with data?
A relationship has two nodes at either end, one node at either end. So it's always connected to two records. It's always got a connection. A record doesn't have to have any relationships connected to it at all.
From the historian's point of view, it's probably more sensible to model the spell as a distinct entity without any actual connection. Because it is just a thing. It's not inherent to... you could read it as inherent to a team and a person.
Yeah.
but actually putting a lot of extra data in there anyway.
I mean, we didn't think about it that much when we built that sort of thing. Thinking about it now, in response to the questions, so by having the spell as a separate thing, as a record rather than a relationship, we can create multiple relationships to and from that spell, so we do gain some flexibility there. But it equally could have been done in the way you're describing.
So it's another login.
These are all really good questions. These are awesome. Wow, we really did go back quite a way.